Okay. Good morning, folks. We're live. Hey, Pepe. Missed the snow up here? Yep. Thankfully. Okay, so let's see. Yesterday, I was just messing around a little bit with the end speed tests. What on earth is wrong with my... Okay, let's just real quick get a new term. So yesterday I was messing around a little bit with the environment profiler. We made a little bit of progress, fixed one pretty bad bug. I mean, it was just a stupid bug. And it was a bug that Claude caught. That tells you how stupid of a bug it is. Alright. Okay, so we were looking at the M speed yesterday. I'll show you what I built real quick with this. Where is it? Tail. Oh, 30? Yeah, so I think it was like M speed, breakout. First of all, single. So this is to match the single threaded perf. Okay, so we have 147 mil single. And then we can do direct, which is using our threaded API, I believe. And I believe that you take a little bit of a hit. Right? One was this 1-0 total agents 1-0-1. Oh, this is 0 threads. So yeah, this is without threading. And then 8192 ends. One buffer, 0 threads. Horizon doesn't really matter, and then 1024. So now this is with 8192M, so way worse cache coherency. It should be 80 something mil. That's not good. Wait, huh? I could swear I had this working yesterday. Why is this all of a sudden not? We had this to 80 mil yesterday. I'm trying to remember if I have different arcs. Buffers, threads, horizon. Yeah, this is super weird. Well, we may or may not want to mess with this right now. Let me think if I want to do this now. Because we definitely have stuff to do on the end bindings. So I guess the things that we can work on today, we have a whole bunch of new networks to port over and things to profile. We have environments to fix bindings for. We have the M speed profiling. We have kernel changes from a contributor to merge in. And other things than that, there's just general cleanup. I think that this is a good thing to work on right now, though. So if we can get our vectorization to be performant, if we can actually have all these tests passing, we should see a nice speed up as well. So yeah, I'll invest some time with this while I'm sort of not still waking up, but getting my mind on this. I spent some time this morning reading the Dumb Dario article. And it's, I've kind of noticed that the like smart writers who write bullshit, every individual paragraph that they write will be fine and very difficult to object to. Every single one will be very difficult to object to, but if you then take the thing as a whole, it's bullshit. All right. Go away, Claude. Oops. All right, so what's going on with this? Oh, it's on GPU. I'm dumb. Okay, yes, I have it correct. Watch this. So test M speed, breakout, 8192 Ms. Yeah. Uh, one buffer. Wait, is it one buffer, 0 threads, D4 horizon. Block says 1 CPU. I was doing GPU transfer with that. Good, 80 mil. So, it goes down from, what was it, 120? No, yeah, 120 to 80. Now this is with no threads. And now if I put this on a background thread, so now there's thread synchronization overhead. This will be super slow, right? Yep, so 8 mil, so that's like terrible, right? But now if I put the block size up to something reasonable, we amortize the threading overhead. And we're at 70 mil. So not terrible, right? And now if I do 4 threads, $270 mil. So that's pretty darn good, right? That's like linear scaling to 4 threads. I think it does get worse if we try to do like 8 and say 512. I think this will be substantially worse. So I don't think it scales like infinitely well. But we'll have to figure that out later. See, so for whatever reason, 8 threads doesn't actually seem to help. We got linear scaling up to 4. We'll figure out the rest of it later. So now the question here, if I put this to GPU, actually, I don't know if this is going to put it on GPU. 40 mil, yeah. Let's just confirm. We go down from 250 mil down to 40 mil. So that's a pretty big hit. So why don't we figure out, so I think it's 119, or yeah, 119 floats times 4 bytes is 476. And then if we assume 32, actually we can just do it this way, 32 gigs. Oops. Dummy. 0.06. This is 60 mil. Is this correct? So if we have 32 gigabytes of bandwidth, is it 32 or 64 for PCIe? I want to see how close we are to theoretical limit. PCIe bandwidth, you know. Okay, so how do I check 32 or 64? Check PCIe with. What? How do I not have LSPCI? Oh, can I do this? Is it in here? Daria's gone totally next level. What? Next level ridiculous, maybe. It's just paranoid propaganda. I read the full thing in bed this morning. Long ass article. I do think that the guy actually thinks he's doing the right thing. He's clearly not, though. Okay, PCIe. This says that we are Gen 5, so we should have 64 gigs. Right? So let me see what, then we're not remotely hitting it, right? It should be 134 mil. SPS should be the cap. So the fastest that I could theoretically get this running should be about 134 mil. Actually, I can get Claude to do this. I just need a very quick bandwidth test to make sure we're actually hitting something like that. Because there's the hardware spec listing, and then there's the actual number that we can hit under optimal conditions. And then that's the number that we want to get close to. Carpathy tweet? Are you kidding me? Man, is this going to be decent? Because I think everybody just needs to shut up and get back to building stuff. It's just yap, 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 yap. Mistakes. This is true. I mean, he's not completely washed, but he's still a bit off base, I think. He's pretty close, but a bit off. This, I think, is bad. No. Whoops. Where'd it go? No, this is not true. This is not true at all. It's close enough to be like almost there, but it's like it's crucially wrong. The thing that he's wrong about here. So the reason that the agents feel so useful, and the reason that you see me using it so much here, is because existing code bases are ass. All right. So because right now I have to deal with the C environments, which are good, but then they have to be bound to C++ via CDLLs. Okay, and then I have CUDA kernels, and obviously CUDA. I have launch functions, which that's how CUDAs work. So you have redundant launch functions. There's the CUDA to C++ barrier, and you have to have headers across that are very redundant. libtorch itself is absolutely disgusting and awful, and the build system is incredibly slow. So it's very, very difficult to quickly iterate manually just because of the compile times. All these things together make it so that whenever I want to make a change, I have to go make a change in like 5 to 10 different places, and I have to keep 4 or 5 different APIs in my head. Yes, the agents are good at dealing with that, but this is bad, right? Like the code should not look like this. Code should be it should be designed such that it is efficient for a human to work with, and by the way, that'll also make it better for the agent to work with and faster anyway. So it's just strictly better. So in some sense, the less effort that you put into making the code good, the less agency you yourself will have over your code bases, right? So this is the thing I actually don't like about these models, is that they reward you being lazy because they give you more of an ability to deal with your lazy mess of code. But that's not what I want to use this for, right? So what I'm essentially trying to do here is I'm using this writing a bunch of throwaway stuff to make sense of this entire mess that I have inherited from Torch plus their stack and how they integrate with CUDA and everything else. And then my goal is that at the end of the day, before this release, I end up with something that is nice and concise and compact and very human friendly, right? That is the difference. If you don't do that last step, you are trolling and you're not actually building something that is going to be long-term useful. Knowledge is not suddenly free. Because here, this is the thing, 20. I can tell you everything I know. I have all these RL guides, right? I mean, I charge companies a lot of money for the stuff that I do. And the prices keep going up every time I release a new update to Puffer and we have new capabilities. So why isn't everybody suddenly able to do this? There's a difference between me telling you something and you understanding something, right? And you need to actually understand the thing in order to be useful and effective. Oops, let me get rid of this bot. Confusing world. Yes, it's very confusing. That's for sure. So my general advice is, yes, you can use the models, but use these models to make sense of the mess out there and to understand and to simplify and to build things, not in order to think for you. Here, like here, let me like write this and let me show you why I'm using it this way. I will explain to you exactly. So you need to sync here. There does have to be... Does there have to be any device synchronization? Let's do both. So, why am I doing this like this? Um, Actually, to be fair, this is me being lazy because I was thinking like, there are a bunch of annoying CUDA APIs, but they're actually not. The thing that's annoying here is just the build script more than anything. Well, let's see if this makes a mess of it. This is a throwaway test though, regardless. Dario is at least a bit honest. He's misguided. I put him above Altman in the sense that he's more honest and he's smarter and more honest than Altman, but I think he's very misguided. I mean, in general, like the Anthropic people are incredibly out of touch. See, like, why the hell is this test so damn long? Right? Because it did this extra thing I didn't ask for. We're often ignoring build stuff. It's not where the profession is headed, dude. You can literally just turn the thing off and build stuff. Hey, Antonio. Yeah, see, woe and behold, this is not remotely how I would have written this test. This test is really crap. I'm going to take this test, but I'm not going to include this in the repo. I'm just going to run this as a throwaway to just see real quick. I really just need a lower bound more than anything. Let's do device. Yeah, it's really stupid it did it this way. Holy. That's really stupid it did it this way. I can do it this way. Infinite gigabytes per second. Heh. Good job. Don't worry, guys, it's AGI. Let me see what the hell it did. Times seconds. Yeah, I don't know why the hell it would do iterations for this. Stupid. So it just ran the test for less than a second. That's so funny. Bytes 1 MB. We have 4 times 118 times 192, 186. We're gonna do chunks of, it's like 3 to 4 megabytes in practice, right? Actually, with buffers, it'll be 2 MB. 2 megabyte bytes. Yeah. Moza, I've been happier. I've been spending less time on X and more time working and on Gillinor. That's what I've been doing in the evenings. There's just so much stupid noise in AI right now. Ooh, 40 gigs a second. Yeah, look at that. 40 gigs per second. Is it consistent? 42 gigs per second. Okay. What's it? Megabytes. 14. 20. There we go. I wonder what happens if I put like a slightly off number, you know? 37 gigs. Oop, that's 20 megs. No, Gillinor is the RuneScape continent, my guy. Alright, 42 gigs. 42 gigs hosted device. I mean, 42 is... I don't know how hard it is to actually hit, How hard is it to hit PCIe bandwidth? Does anybody know? Like, what's the realistic? Ah, okay. So it's the synchronizations. Because the mem copies are very, very fast, right? How many liters? 1200. Publish paper. I don't really need to publish anymore, man. Unless I'm on pubs that are like collaborations with academic labs, it's mostly a waste of my time. Yeah. Okay, so we're only hitting 40 gigs. And this is with like their fancy test. It should be very close. Let me go look at this test. And then what is it? 190K itters? Hmm. And how long is this test? It's like a 5-second test. Yeah, so these checks should be fine. There's 4 MB. We'll do 8 MB maybe. Somewhere up to 45, 48. It actually doesn't seem like it has to be bound synced. Oh, of course not. It's aligned to news. Oh, okay. So that it does actually increase. Interesting. Then you get 10K itters. I wonder if it's this stupid, it's probably this get time in seconds, right? Wait. What's the resolution of this? Clock get time. No, because we have... This is fine. Yeah, it's nanos... Okay, so it's not that. Do you need, like, really big blocks? 128 MB blocks? MB blocks. Yeah, it's not faster. I mean, if that is the practical limitation, though, of what we have, unless I'm doing something wrong here. CUDA sample test. Oh, is there one? Out of date. This looks good. Buffer size with copies. Okay. Can run the following to install. This looks good. Oh. Is this included? Nope, not included. And this is the new one anyways. Clone this. It's very important that we have a good baseline. It's worth taking a little bit to make sure. This is basically, we just want to make sure that we have an accurate estimate of how fast our thing could be. Hey, user. Failed to detect a default CUDA architecture. Really? The NV bandwidth? I think I probably just have to set this flag. That works. Build files have been written. Okay. Can you make it fit in L2 cache? What's the cache size, and shouldn't it do that automatically if it fits? Wait, why should that even matter? It's a pure bandwidth test. This should be testing PCIe speed, right? Ah, there we go, look. This is the exact same as my test gave. Kernel transfer, what? Well, I mean, this is possibly a setup issue with the machine. PCIe X8. Oh, that would be interesting. No, it's 16. It is 16. IOMMU. Nope. Oh, wait. LSPCI. Hang on. Let me try this. Why mess up? Just find it myself. Is not in pass through. That could be. Well, I don't see it on the host device though. Unless this rep is wrong. Should it show up in dmessage like this? Oh, here it is, 14. Device. Is this the 5090? This is, right? I can set this up on the host real quick. It should show in dmessage. It doesn't. I see group 14 here. 32, wait. Why is it 32 GT? Eh? Oh, that is 5. I don't know what GT is. Default, if it is in PT mode, it should show. So then what should I do? Should I just set up this test real quick on the host? Let me set this up on the host then real quick. That should do it, right? I did check it on the host. I didn't see it. Ah, shoot. Okay, I don't even have CUDA on. Yeah, CUDA's just on the That's annoying. I forgot about that. Let me try one more time. As you said, this should show in D message. This, right? This should work. Not there. When you say start the kernel with IOM. Wait, start what kernel? Oh, the OS? Is not enabled. Okay. So then why is it slow? Where are we losing our perf? It's not on the wrong socket. There's one node. We don't have that anyways. Okay, well, there's a hardware setup quirk. We don't really need to worry too much though, because the hardware is what the hardware is. It does mean that we should include some sort of little memory bin with test with Puffer, but we're capped to about 48 gigs at the best. So let's go look now. And let's just like see if we can get the code to be near the hardware's cap at the moment. Okay, so the 119 times 4, so 48 gigs divided by about this much bandwidth. So this should be 83 mil should be the cap. Yeah, 83 mil should be the cap. Oh, and let me think, because we have, let's go check our tests again. And what do we do? do 119 times 4096. Hang on, times 4. Close to device 196. 46 GB. Okay, so this says that we should be able to hit the pretty much the peak with these settings. So this is pretty much the hardware peak here, and we should be able to hit it with this size of a copy. One buffer, 4 threads, and 1. Block size. $34 mil. We're looking for 80 mil, right? We're looking for about 80 mil. Let's go to 8192. 2 buffers. Okay, well that's faster than it's supposed to be able to go. Yeah, that is faster than it's supposed to be able to go. Though not faster than the hardware is supposed to be able to go. Possibly we did something weird with double queuing it. If I do 4 buffers, does it get better? Okay, so that's faster than it's supposed to be able to go. So then the test is wrong. That's annoying. What are we doing today? We're trying to get accurate profiling information on our vectorization, and we're going to try to see if we can get our vectorization to be about as fast as the hardware bandwidth. You see, like, I believe, if we were to do, like, 48 divided by... This is the GPU drive one. It should be able to get to 6 million. So yeah, our vec is slow at the moment. Yep. I see the bug. Good obs action reward design. Wait, what? It depends on the problem. Typically, one of the easiest things to do is just think about what would happen if you were trying to build the game for a Game Boy, or the environment in general for a Game Boy. That'll get you a nice action space. Ob space can be tricky, though. Doesn't work for everything as well. Some things are very difficult to put into a nice action space. It's very important to do it, though. Okay, so this is no longer going to be a bajillion steps per second, right? Okay, that gets us 50 mil, though. Okay. 50 mil up from, what, 30 mil? What about with 2 buffers? 46. What if we do 16, 3, 8, 4, 4 buffers? We're basically going to play with this for a bit until I'm convinced it's like problem, or like this is how it scales. I just want to play with this for a little bit. Okay, so it's going to be 1 buffer now. I'm going to do CPU. How fast this goes in CPU. Writing it. I've started writing it, man. I have not finished it yet. In particular, it bothers me that this doesn't work. Oh no, that does work. You get diminishing returns, but it does work. Okay. If I do 16 threads. I mean, we get over 200 millisteps per second vectorized. Okay, so you do actually crush it under a certain point. But this is quite nice. So what if I now go to this, 4 buffers? Working with Bipin. Now I'm more on your side. Yeah. I mean, the more I use the model, the more I think, like, it's really not smart. It's really pretty dumb. Like the elite engineers are, you do, like, just having the model write all their code. It's actually, like, it's really the dumb engineers are having it write all their code. And the good engineers are having, like, apply basically glorified refactor and reformat things. It's really not doing all that novel of work. It's really just good for the drudgery. So, like, okay, automating all the drudgery to be able to program stuff faster, and I'm still thinking about all the hard problems at the level of line-by-line code. But of course, they take that and they just, like, completely lie. And you can't make it do anything hard if you want good. Yeah, no. So Scarsh, I use it for. I mostly use it to apply templating, if that makes sense. So I have this piece of code over here that looks like this, that came from this piece of code over here that looks like that, and now I have this other piece of code like that, and it needs to be ported over to this thing to look like this, right? It's pretty much like pretty like straightforward, unambiguous refactor ops. It's just that I have a lot of those right now because of what this current project is. So it looks like it's very useful, but generally it's nowhere near as much. So, like, am I going to be using this for everything, like, everywhere? No. Okay, so we get 53 mil. We should be hitting 80 mil. Let's go check this one. Vec reset. Okay, so this one is full async here. And then vec receive. I'm going to comment this just for a second because I think this could be it. Oh, you have a synchronize in here, dude. Hang on. Yeah, you have it synchronized right here. Of course, this is a mess. Only up to 54 mil from that, really. Back threading. If I go back to more reasonable settings. Okay, yeah, that was not the play. Don't let me forget to undo this, guys. It'll break stuff. I gotta have, I just want to make sure we don't have any other weird operations in here. Like, there should be no synchronizations. CUDA mem copy. Ah. Wait, CUDA mem copy. Oh, that's fine. That's on startup. These are all async copies. That's pretty much fine, isn't it? Oh, you know what? There's one other thing I want to try. Hang on. So we said that this one is not the bottleneck, right? So this is our test setting. And how fast is this on CPU? $267. So this is what, 5x faster? So it should be like 20% overhead. That's pretty close. How about we do the drive end? The drive end will be more interesting, I think. Ah, this might be too much. Hmm. Eight agents, one buffer, 0 threads. It says 8 on CPU. Can we do this one? Very slow. Very, very slow. Well, this will be the thing that we have to figure out. Let me use the restroom real quick, and then we will continue on this. Grab a cup of tea as well. Okay. Yeah. Let's figure out what's going on here. We get this proof test, please. Great. This is with random movements. 1.1 mil, right? If I just do this. Okay, you should be able to at least get it over a mil. Just to make sure the time is not going to screw us up, the time call. I don't think it does. Yeah, 1.1 million steps per second. See? Okay, 1.1 mil steps per second. Done much with Majoko? Oh, geez, man. Majoko, Masloko. If you want the slowest damn simulation ever, then yeah, sure, have fun. Huh? Wait, what? Is it stupid? Is it like completely stupid? That does not seem right to me. Yeah, what the heck is this doing? Why is it doing this? Total agents. Yours ready for users and hardware integration. Ready for users, yes. We are not a robotics company, man. We're an RL company. We do general purpose RL. If people want us to do robotics, then sure, we do a few things with hardware. Low dimensional hardware, drones, but it's not our main business. We do general purpose RL. Most of our stuff is very heavily focused on like enabling stupidly fast simulation and then enabling the RL loop to keep up with that. So Puffer 4 is going to be above 10 million steps per second training on one GPU. And you can do a lot when stuff is that fast. Trying to see what the heck is wrong. Yeah, okay. Let me make sure I'm not miscounting. 1.1 mil. Something's different between these two. It's like, okay, the risks due to engineered nanoparticle swarms are also massive. I can just make shit up as well. Essay does not recall. Yes, it does. They've actively supported major restrictive legislation repeatedly over the last several years. Oh. Whoops. So it is just a dumb bug. This is why I don't let Claude write tests, even really basic ones. Oops. This should still be 120 mil. %, conspiracy theory. That's just social media, dude. Literally all of them are like that. And yes, it is based on shit that you click on. If you just click not interested on like 10 of those posts, they'll go away. It's like I click on one RuneScape post and now I've got 20% RuneScape in my timeline, right? You don't even have to like the post, just clicking on it is enough. Okay, so this now works, right? Yes. 192. One buffer. Zero threads. 64. And 12. Oh, wait, there should be one other test. Do this first. For a few weeks. No, well, I mean, in my case, it's directly tied to my business, so it's a bit different. Ah, okay, so this is another story. Look at this. This gives it this massive haircut to performance somehow. You see this? Now, this is consistent, I'd say, with our earlier findings, but that's like really big. What if I do 256? Does it really just like screw up caching that bad? Is that what I'm seeing? Hmm. Yeah, something's screwy here. Is it? No, 256 doesn't fit in the cache either. Huh. PCI. This is a mix of things. So we're testing both CPU speeds and scaling, and then also PCIe. Hit me up when you want to integrate. Oh, okay, awesome. Let me finish this thought, and then we'll integrate your PPO kernel stuff. Yeah, there is. All right, well, I can take a break from this to go on the kernels because those are gonna be a nice win. Let's go take a look at what you got. Pull up the new, not Gmail, GitHub. So this is Peru stuff. Oh yeah, folks, please start the Puffer on GitHub if you haven't already. It does help me out a ton. It's absolutely free. Adding grad 2 times. What? No, it's not. Let me see. What? I literally have tested this. Okay, I'll look at that later. I'm pretty sure this is wrong, but we'll double check it. Okay, let's go find your stuff. I got distracted because that was so weird. Uh, fix issues. Tensors were not contiguous. Kernel does square root. Okay. Logit stride. This is the profile file. Let's go look at the other one. Do you need all these stride? I see. I think you could simplify this, but I can simplify this as long as it's correct. Just, yeah, let me get this board. Hang on. Lovely. We got the CLI Discord updates. It still does that. Oops. Kaboom. Where am I looking for messages? General or dev or something? I have it open regardless. Where'd your thing go? Here. Strides, this is what I would expect. And then you put the square root into the kernel. That's fine. Okay, this is what I would expect. Was this seriously the only issue? Messy, but if this works, I'm very, very happy with it because I can clean stuff up as long as it is correct. In fact, I'm probably going to do all day stream Thursday cleaning stuff up if we get perf to be good by then. I can merge this directly, actually. Solid PR. Blah, 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 blah. Checks failed. Don't matter. Merge. DM do? Okay, accept DM. Need the strides, made variants, because auto, MB, blah, 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 single kernel launch. Introduced this kernel. Wait, oh, Torch has var mean? I didn't know Torch has var mean. That's cool. Dude, thank you. This is sweet. Let me rebuild this. I mean, I got so close with this kernel, and I was like, what the heck is wrong with it? I wonder if it's... You said training stable, though, so... Let's see if we get training stable. The annoying thing is there's probably still some very small numeric stuff to deal with still, but... If this works, I have plenty of other stuff you can do on here. Ooh. That's over 11 mil right there. We are not getting any stats back, but hang on. This probably was me breaking it, though. What the heck is wrong with this? I think this is me screwing it up. Hang on. Stuff LLMs. This is stuff what else? Yeah, exactly. I did. I don't think this is your bug, man. Yeah, I think I broke something with this here. Let me figure it out. Because I've been messing with the end builds. I did rebuild though. Agents per buffer. Ah. Well, I don't know why this would break it, but skips up to 4. Oh, there we go. Oh, I think frame skip set to 0 literally does nothing then, right? Okay, so we don't get 11 out of it. There is environment in the loop. What did you get 12 mil out of, man? How'd you hit 12? I mean, that's still like nicely over 10. It was when it jumped at the end. Ah, okay. But when it jumps at the end, for me, it jumps to like 25 mil, which is the eval speed. Eval speed should be way faster than train speed. Say like 25. Boom. Hey, that's still a solid contribution though. That's a nice bit of speed. That cleans up our kernel calls as well, makes profiling easier. Yeah, and you have it here. Yeah, this is good. Oh, I see what you did here. This is yeah, so one thing we were experimenting here with Jonah, I think you could pre-compute this over the entire batch rather than just a mini batch. But that is something that we'd have to ablate, I suppose. This is a very nice contribution. Okay, so I guess then, is there more stuff that you would like to do? Because I could always, if you want stuff to do, you could always try out BF16. I actually, hang on, is there a way that you can write a matrix output to a different D type? Oops. Just cast it? Well, no, a cast is a kernel, dude. So you defeat the point. Casts are kernels. Autocast. Temporary BF16 copy. Is this all it does? In the kernel, you cast it. It's too late if you do it in the kernel, man. The point is that you, if you do it in the kernel, you've already wasted the memory bandwidth, right? So the point is that the inputs going into the kernel will be half the size. Inputs in BF16, yes. All computation can occur in FP32 and just downcast at the end. Yeah, so that's what we would want. We'd either want that or we do the matmul's in BF16. So for the kernels, that's what we want to do, is inputs BF16. But in order for that to make sense, we have to be able to handle the matmul's without having redundant casts. Let me see if I can look into this a little bit, and then either I start on it or maybe I can give it to you if you want. But I want to see if it's actually doable. Yeah, so like this pattern here, you see that this pattern is bad, right? Because that, like, you've already wasted anything that you would save, you've already wasted. I think you'd have to do it manually, right? Okay, so one thing that I can see here. Yeah, you see, do you see this thing that I have at the bottom here? This sync FP16, FP32. So, like, one thing that I could see doing, Jonah, would be here. Tell me if this makes sense and if you'd be interested in trying this. So, like, the problem is the matmul's, right? So you have, like, matmul, gate, matmul, gate. So one thing you could do is you can do this can be, so inside this matmul, right, you actually have 32, and then you have W16. Whoops. And you use W16 for the matmul's. How does this work for training? Does this work for training? Yeah, it does work for training. And then when you do the gradient updates, you use this one. And then in between gradient updates, you sync these two back and forth. In between gradient updates. Would that do it? So then that should cut that cuts your memory bandwidth in half for all of training at the price of doing one additional weight synchronization per optim step. The question then is going to be, is that faster and is that stable? Like, the key here is that this is already in 16, right? And then the output is in 16, and then the gate gets 16. It does internally, it does 32, but that's not incurring like the memory bandwidth for the inputs. How your weights are stored throughout. Yeah, that's why I wasn't going to use Torch Autocast, right? You'd basically just store extra weights. Like, this is how I did it for this one, right? Because I was playing with this before, so you just grab the two policies. So you just make two copies of your policy, right? And you just iterate through the params and you do this copy underscore. So this should be 0. Let me see. Is this 0 kernels? It's slightly annoying because every single one of these casts is a kernel. Like, if you were smarter about it, you could technically have it be 1 kernel. But this is not bad. It's 1 kernel per weight. It'll get coup de graphed anyways. Decided to write some M's. Just worked through the full Flappy Bird game looking for a larger project to do. Ooh. Any suggestions or things that would be useful? I'd have to see how the Flappy Bird code looks. Generally, the best thing for newcomers to do is to then, if you've done that, then write something that's more of like a reasonable arcade game. Or the original ones for this. I wonder how hard Sequest would be. Okay, I gotta be a little bit careful with you because, like, some of these end up being way harder than you would expect. We have Pong, we have Breakout. A lot of the Atari arcade games are good newcomer projects if you just pick one that looks reasonably simple that hasn't been done and that has already been used in a bunch of papers. Aim for something that you can do in like, 400 to 600 lines as a second project. Goal is to have weights and input stored in 16 bits and then all computation in 32. Well, you can do it either way, right? So you could do, I think that the gates should stay in 32-bit. Right? There's not really much benefit to trying to do the gates in 16-bit anyways. So all of our custom kernels should be the computations in 32. But then this does open up the possibility for us to do the matmuls in BF16 with the tensor cores. That should be dramatically faster, especially as the net sizes get bigger. So what I would expect is you get some benefit to doing that with our current net sizes. But then the cool thing about this should be that if you then, let's say that we do 512 hidden dim, everything should get way faster. So this update would actually, it's not going to make a huge difference, I don't think. Well, hang on. The memory bandwidth will make a big difference for small models, but then doing the computation in BF16 would make a large difference for bigger models. Is my expectation. Because, like, I don't know, 5090. Where are the specs? Peak. It's bigger either way. I forget how much, but BF16 should be much faster than TF32. So let me reopen this chat window because my dock broke somehow. There. If you've said anything else, Joan, it hasn't showed up. I just see your Discord message. Chat's being weird. But yeah, that would be my next suggestion. And go back to doing env debugging. Unless there's stuff to discuss on that. Is my YouTube chat full broken? No, it's not. I think it's okay. More questions as I'm looking into it? Sounds good. I'm here all day. Yeah, I think that's probably the last major optimization. That and the env stuff I'm working on for 4.0. That'd be so funny though. We end up getting like 15 mil. The thing is, I didn't get a huge benefit from BF16 before, but I think it was because everything else was so inefficient. You know, matmls were a very small fraction of the compute time. But now that it's quite a big fraction, it should be better. Drive env struct size. Ooh, that would be weird. Let me actually try something real quick. Oops. I'm gonna do a quick experiment. One mil, right? With no obs. Four mil. 2.4 mil. So it's pretty much on par with what you would expect. Huh. Still thrashing pretty bad. It's not even iterating over the obs though. Wait, is it? No, not as bad actually now. I think I can do this myself. Yo guys, is the chat working? I don't know if my chat's broke. Let me go check YouTube. Because it did something weird. I think it's working. It gets M star, right? How about I do like this? Oh wait, is it in test direct? Profile vec step direct. Vec step direct. Okay, so what I'm gonna do here, right, is now it's gonna step all the M's and then compute all the obs, and I just want to see if this makes a difference with the caching somehow. It'd be kind of funny. It's probably worse to load everything twice. About the same. Well, no need to do that then. It's just caching. It's just caching. Okay, so now we know that the drive M's actually kinda slow. Now let's see how much faster we can get it. Do this, and then we're gonna start doing a couple tests. Get it to like 2 mil maybe. So we're going to do A192 agents, 1 buffer, 0 threads, 64 horizon, CPU. Slower environment, and should be able to parallelize more. He's pretty bullshit. Uh-oh, what's wrong with this test? That's kind of weird. It's probably just doing too many loops, right? Alright, let's fix this real quick. Yeah, there you go. We'll do like this instead. Okay, so this matches, right? 0.46 mil. You know what it is? Where's the telescope and blind? Was it telescope and cane some meme? This one? Where's the Okay, yeah, it's this freaking meme, right? It's like there are multiple ways to lie about stuff. You can still lie about stuff while writing things that are entirely true, right? If you just devote 90% of the attention and hype around the like small like the downsides and then 10% on the really good upsides, you've still completely misrepresented everything without writing anything that's technically directly untrue, right? That's what like a lot of like smarter but uh, manipulative people will do, because then it's very difficult to like call them out directly because they haven't lied about anything. They've just like set a bad narrative, so to speak. And that kind of requires understanding what they're doing. Actually, the more I think about it, the more it's literally the 2027 playbook, right? It's the exact same thing. Gigantic essay with about like 90% made up downsides that you can't technically refute as impossible, and then almost nothing about like, oh, also this could be the most positive thing ever for humanity. It's the same thing. Man, it took me a while to actually draw the connection as well, because like it is well written and it was a dramatically better executed piece than the original one. The original one was like it was well written for masses, but it was still sort of a sloppy hit piece on AI. This one is like way more intelligent and I think more sincere as well, though maybe it's just very well crafted. Um, it's still all bollocks though. Why does this thing take so long? Oh, because you did the wrong one, dummy. Wait. M speed direct. Oh, you've got this as well, right? Yeah, like this. Now this should only be a few seconds. 0.44 mil. I think I need to get better at doing that as well, like at pointing out. I gotta make that. Maybe I'll just post that later. This takes. How does this still take forever? This is weird. Oh, because you're stupid. You keep doing it wrong. Why? Yeah, I keep doing it wrong. Damn it. Okay. This, 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 this. Fine. There. Should be better. It's a quick test, and now And now we can start looking at scaling. Right? Yes. Good. First test, one thread. Okay, 0.43, still good. Buffers will go up to 4 threads. .78. That scales absolutely terribly. Why is that the case? If I do breakout, does it scale the same? Oh, this is also slow. Why is this also slow? Huh? Blocks, wait. Name. Buffers. Threads. Yeah, something is screwed up here. Actually, hang on. Something's very weird. These perf tests are so fiddly. Is it just the warm-up? Okay, something is totally messed up. Is it this? Basically just need to get this to feel consistent. Yeah, something is completely messed up. What did I do? What did I do? Yeah, no, something just broke. Something totally just broke. Locked in Hayoff Market. I have no idea what the heck is wrong with my restream chat. It's just not working here. I still see it on the stream, but like my dock I normally have is just broken. That's okay, I guess. Yeah, look at this. What the heck just changed? No. No, I don't have weird flags. Let me use the restroom real quick. I'll be right back. Man, this is like the annoying thing with profiling. You have to be so incredibly careful with these. Okay, I got a couple ideas. Nothing is running. $106 million, right? There goes that one. Hey Jess, I'm trying to get some good profiles on our vectorization. Let's see if we can figure out where things are fast or not. Working auto-tune. Well, just it depends. You might not need one. It might just work consistently. Sweep for SPS. Specific. Yeah, but that's the thing. You may or may not actually need that in the new version, Jess. Like, a lot of the stuff that felt jank with that was jank because of PyTorch. You can watch our agent play chess as well if Jess has that. uh, that's absolutely stupid as hell. That's why you don't reply to stuff. I mean, something changed. Total agents. I didn't change any of this, though. I'm trying to think what the heck I could have messed with. People. Yeah, it's a pretty dumb comparison, frankly. So, I mean, this is just, like, impossible, right? Oh, this is it. Thank you. Thank you. That's what I forgot to change back. Finding dense rewards don't help. Seems terms are sufficient. Yeah, the RL's pretty good, Jess. Just needs a lot of data and a decent neural net. Okay, this is not going to help us very much, unfortunately, on the rest of stuff, but 8192. Buffers will be one buffer, one thread, 64, 12. That is terrible. That is actually terrible. Why is it? Oh, no, it's not. I'm done. Okay, this is totally fine. It's okay. Gotta actually remember things. Come on. Like having to make sure I'm not forgetting. Okay, good. That is what we want. Drive like this. Checkers and getting 100% win rate. That is good. And should be getting 100% win rate. Checkers kind of easy for the puffer. Okay, so this scales terribly, right? Now let's go to frame skip 4. Oops. So at frame skip 4, get 14 mil. That's still like crazy slow. But how's it scaled? $43 mil. It's not bad. Then if I get up to like 8, give it 2 buffers. I don't think that does anything on CPU. $40 mil. CNN alternatives, better CNN results, much better learning, but is slow. You could do maybe much better learning, but is slow. Yeah, that one's annoying. That one is pretty annoying, honestly. The encoding for chess is probably sort of weird, I'd imagine. Okay, let's first of all, let's figure out why this thing is so freaking slow. Single. So we get 19 mil. Liking the glasses, I wear them when I don't feel like putting in my contacts for the day. Ooh. Really? This is interesting. This is way too slow. Five mil steps. Ah, there we go. 27 mil. Without D&D bug. Yeah, you dummy. 25 mil, so we can leave D&D bug. Oh, 4. Yeah, no. And O3 is slower than O2, which is normally what we see. Okay, so now we get a reasonable number. 24 million steps per second. Let's build back. Single. $18 mil. form. Speed single. Where's M speed single? Thousand. It's fine. No inlining. Yeah, that's the first thing I tried as well. All right. But still, we get 19 mil. Cool. Direct. So it's a 19 mil env. It's down to 14 mil. And now we run it with the reasonable args. 2 buffers, 8 threads. Only 2x faster is not good. Yeah, this scale's awful. 6 mil. Is 8 even faster? So it even work? Oh, scale's not great. We only get about 2x faster. Okay. But if I do drive, and actually this one I need to do, let's do 100, 100. Yeah, because we can't have, we can't be having these crazy numbers here. Really, this does not scale very well at all. Mm-mm. So this deck is not performing as it should. Really not at all. This should be like stupid fast. Okay, so I mean, we don't even need to do drive for this, right? This is just like not doing what it should. 37 on 8 cores. 3x from 8 cores. Yeah, like no matter what you set it to, it just does not scale. That's not good. Well, let's make sure that the M speed test itself is not to blame. Make sure it's not these device synchronizes. Oh, okay. It is the device synchronizes to some reasonable extent. Wait, I'm on CPU, dude. What? Wait. Wait, what? That should not have done anything. Is this going to GPU? Why did my test just randomly get way faster? I mean, it's still nowhere near where it should be. That's where it should be. And then what? It just doesn't scale more than that? Yeah, okay, it doesn't scale above a few threads, it seems. Even if I give them each, like, more work. No. caching just destroys you. I honestly don't even know. Do I believe that? Hang on. Hang on. That is what we get from the direct profile. Let me go double check this. Okay, so if I now go to 4, it still scales awful. Uh-uh. Yeah, it's not working right. This is very annoying as well because, like, this should be an amazing, amazing VEC implementation. It's got this atomic load. Are they just fighting over too many atomics? Is that what it is? Hang on. I mean, I'm giving it quite large blocks of work. Do you have to give it, like, way bigger? No. Hmm. Threading is just, like, the worst thing ever, man. I mean, this is just really, like, not a very good vector implementation, frankly, from what I can say. And this does not scale well at all. 64 to 128 what, dude? This is very disappointing. I mean, I wrote this to be like the awesome VEC implementation. I mean, we're gonna have to like profile this and figure it out. Yeah, I've tried both, dude. I've tried. You can go super low as well. Like, you get way more overhead if you go low. I mean, I have 16 threads. I should be able to use them. But you only get 24 mil. Yeah, no, it's... You get to 27 mil with this. So I don't understand why why it's so much slower with that many more M's. Like, you should only be able to be so bad in your caching, right? I just want to make sure we're not doing some like stupid cringe stuff. Okay, this is the 22 mil from before, right? Oh, okay. Hang on. Ah. It's the DLL being shit. That's interesting. Huh. Well, we found something, guys. Somehow the DLL is injecting this, like, weird latency. Huh. That's very, very odd. Alright.
I'm gonna use the restroom and get myself another mug of tea. And we'll figure out why this is doing absolute bullshit.
Okay. I got Mrs. some toast as well. Mm. It's pretty weird. Hmm. Hmm. Yeah, it's gonna need all these. We'll let it mess around for a bit though, because it basically we have the problem. We just have to go try a few things. Oop. Mhm. What? So that doesn't help, which is good because that would be really screwed up if that was the memory layout issue. Because we can't do anything about the memory layout in practice. It'll mess up the copies. So we're happy that that's not the issue. Claude, check X. Yeah, I gotta stop doing that shit. That's really bad. Right? Interrupts your train of thought. Um, but right now I'm mostly just being pissed off by DLLs being weird. Let's go print this. Yeah, this is fun. like I've already found the bug, right? Like I found the issue, and now it's just a matter of isolating it, which takes a bit. But like we have it like we're pretty clear what's going on. You know? Oh, you know what? Hang on. Let me try one other thing real quick. Oh, that just makes it even faster, funny enough. Huh. It's not that. Skip. These widths are different. Wait, what? Hang on. Where the hell did these args come from, man? Dude. I had no idea where these came from. There's nothing right here. How on earth did this get wrong? Must have let the stupid LM autocomplete. Jesus. God, that is so bad. Oh my god. It was so stupid. Okay, we're still 20 mil though. Hang on. What about the initial paddle width? Initial paddle width. $24 mil. Test performance. And then the single test. Yeah, the args were all messed up. Let's go check the multi one just in case. I think this one should be more stable. I do think that this one should be a more stable test. Because if you don't do this one, like if you don't do this one, there can just be like weird little caching differences. Everything is so tiny. Alright, let's try this one. 24 goes down to... Ooh, 17, look at that. It does go down to 17 mil. But now this one's down to 15 mil. I'm in the exact same state as allocate. Should. I don't think we have this. Well, I'm a little bit suspicious. The thing is, I'm suspicious that something is not scaling correctly. Oh, well, this is, hang on. So this should now be, what's it, 14, 15 mil? Okay, this is still the same speed. Goes up to 40 mil. And just stop scaling, right? Yeah, just stop scaling. Hard stops. Yeah, it looks like threading contention, but I thought that I optimized that. Like, it should be very low overhead. It should be, at least. Okay. Wait, what? Thread completed. Wait, threading completed. I think this is a mess. Let's see. Actually, you know what? We should just be able to do. Yeah, because we really want to like get a test where we know that it's. Oh, okay. So you actually do crush your perf. When you just have a ton of ends, huh? Okay, but then this should be easy for testing, no? If I just do. Okay, 5.9. It's the same thing, right? Now we go to 4. I don't understand how this scales so freaking terribly. Taking too big of a hit for having a lot of ends. This I want to see. Hey, this is way better than the other stuff that's been putting on my timeline, right? Specialized. 83% of coup blasts. Other spinning threads. There's 2 threads. Vec receive. Other spinning threads. Shouldn't the scheduler, so it should scale to 14 then. You bench 500? No. There's not a single person in the world that looks like I do that benches 500 pounds, dude. Are you kidding me? My best was 265. At the moment, can still do a few reps at 2 plates. I did a set of 5 a couple weeks back. I'm trying to fix the shoulder injury, though, before I try to, like, push the weight too much again. I mean, it really should be easy to get better scaling than this. Oh, I guess it would be... No. Alright, even if the mutex takes forever to acquire, like, we just have really big blocks. And also this time here, this processing time is also per block. So I don't actually see how it's possible for this to not scale. Okay, we can watch H-top, I suppose. Well, hang on, wait, why do I have all these cores at 100? Why am I seeing these cores at 100? Why? I don't have NVIM open. What the heck is going on here? Do I have stuff on root or something? Oh. Wait, what? Hang on, I might just be a moron. Actually, let's leave this. That'd be very embarrassing. Okay, now there's nothing, right? There. $18 million. Yep, same perf as before on this. What the heck does this do? Okay. I don't think I even have that set up. We can try that. P. Geeks for geeks. Where is the stupid thing? Oh, wait, what? So then wait, is it? Do I not have it? Is it this? Okay, this thing is completely stupid. Yeah, this thing's completely freaking stupid. There we go. Huh. That's kind of nice. I mean, it's not scaling anywhere near as well as I would expect it to. It's very sad, though, that that's better than my implementation out of the box. That's kind of a problem. That's not good parallelism. Same scaling pattern. Scaling due to memory and cache. Okay, so it's both. Oh, duh, you idiot. It's going to be membound. Wait, is it going to be? 32. It's the scale to 32. No. Hardware threads. Okay, so it doesn't just go to like the number of ends times the number of threads, right? So the most we can expect to get is this 25 mil. At 8 threads, we're the same. Okay, let me try with the drive env actually. This is kind of interesting. processing. Open MP. Just make such a mess. If they don't, but the map does, unfortunately. This does mean heavier M's will scale better. It's just GPU drive isn't compute heavy, it's memory heavy. It's the problem. So, I mean, what this means is we need some test M's. Yeah, we definitely need some test M's. What? What the heck happened? Where's the map ID? Oh, it's using the wrong one. we'll just make a puffer env. We'll do like a synthetic puffer env. For benchmarking. Yeah, I'm gonna just like skim through this because I think what we have to do, we need to distinguish between compute bound and memory bound environments, and we need to have tests for both of those. Okay. What time is this? 2 already. I also don't want to work on this one thing all day. I'd like to do something more manual as well, not just this crappy like throwaway test with Claude. Maybe that's what we'll do, is we'll do yeah, maybe we'll do like an actual proper test um for the vec. Yeah, so this thing just made a complete mess. This is why you don't do this. This is exactly why you don't do what I'm doing right here. Like this, what the fuck? Awful. Like awful. Yeah, so this test is basically worthless now. It's gotten clotted to the point like this is indecipherable garbage code. Yep, there you go. Okay, so this test is broke now. Uh, I'd like to say yep. That's actually a perfect example of why you don't do that. It wrote a whole bunch of garbage and then just broke it. Okay. A total piece of shit. Yeah, this is just all undoing things. Cool. Okay, so what have we learned? From what we've done today so far, we fixed a few bugs. We've learned uh, there's definitely a fundamental scaling limitation. We've learned that I should have had a synthetic benchmark env a long time ago, so we can isolate membound versus compute bound. I've learned, though I should have known this a long time ago, incredibly stupid, that when EMs get this fast, them being membound does more than just make them slow on transfer to GPU. They also fight each other when you go to thread them. So that was kind of obvious, but meh. I'm going to take a few minutes and I'm going to reset a little bit, and then I'm going to come back and what we're going to do is we're going to write like a synthetic env that is either just like a thunk, does nothing, or is incredibly memory bound, or is incredibly compute bound. And then what we'll be able to do is we'll see how Puffer scales in all three cases, right? I'll be right back.
Oops.
There we go. Can't you slash rewind back? I didn't know that. Whatever. We're gonna do our own thing now anyways. Don't need any of this crap. Let's get all the requireds out of the way. Terminals. Does nothing. Make the benchmark inferior. Okay, so this one will actually do something. Funk. Cute. Actually, we can do better. We can just do it. Band width. Cute. Compute, right? How do we get something that's not going to get optimized out? This is for testing generally. Is there something better than tanh, or they're like hash functions? Pow xy. Yeah, I think that it would just do this. Well, hang on. Do I want to do this in a loop or as a mem set? I think we do it in a loop. Yeah, like this. Get rid of this. C close. Okay, there's your basic env, right? It'll be easy enough. And we can just run this super easy. No need to have this. You can just do like this. Char. Start. Long num steps. This is fine. Ooh, this one's a little iffy. Well, we can check this in a second. Steps per second. Put 0 in here. Yeah, there you go. That's actually a really expensive op. That's a really expensive op, holy. Let's try this one. One. That's better. Yeah. So now you can, you can crank it up to 100 signs. That's super nice. Don't really need to warm it up, do you? CPU benchmark. Yeah, that's fine. So 1, 2, 4. Bandwidth is stupidly massive. How does this make sense? This cannot be right, can it? Wait, is that... What is memory bandwidth? Is that like remotely realistic? I put like a meg? No, it's just not doing it. It's like optimizing it out. Hmm. How is this possible? Result equals 0. Yeah, but it shouldn't be able to cache that, right? Now I just did this, right? I didn't think it could cache it though because it's not compile time. Like this compute variable is not compile time. It can't have infinite bandwidth. Puffer 6? No plans for Puffer 6 yet, Jess. Like, we'll make it, but I don't know what it's gonna be. Presumably, we have a heck of a lot of stuff solved by then. Oh. I see. There we go. There we go. This is again still too much. Interesting. It's like the compiler's doing something weird. Okay, I think we can do this then, right? There we go. There we go. Yep, so now we get 50 gigs if it doesn't fit L3. Cool. Okay, so once you go above 63, so this is what was happening basically, right? Is we just had the entire test for some of these fitting in L3. You go down to 50 mil. But hey, that's pretty cool. That's pretty cool. Restream is kill. May have spammed you. Thought my messages were just being eaten. Your messages were just being eaten. They're not showing up correctly. I have no idea why. Restream's been screwy today. Like, I see your messages on the chat window, Jess, which wasn't working before. And I don't see them on the screen above me, which usually that shouldn't be possible. Something's super broken. Okay, this is way more reasonable. Find an alternative. It pretty much just has to hook into OBS and connect to X, Twitch, and YouTube. People have told me I should try Streamlabs. I might just do that. I think that's annoying because I don't think it's a plugin. I think it's like a replacement for OBS. And OBS is the super stable thing that actually works. Cute. What in the hell? Absolute freaking goober. Rest of this is fine. Do you need to include OMP like that? Total obs. Okay. Why? Why do you need to? Oh. Dash LLMP. F open MP. Ah. Does that do it? Yeah, you have to do like this. Oops. Okay, now we go down to 0. Back to 320 millisteps per second. Just nice. Two. Okay. Very nice. One thread. Still nice and fast. Perfect. 4 threads. It's 4 times as much. 8 threads. No more scaling. Alright. Now we do some compute iterations. Make it a little slower even. Okay, so now we have 0.1 millisteps per second. This scales x3. This scales x8. Not quite 16. Interesting. Not quite 16x. You get 14x. It's not bad. So ideal workload, you get 14x. That's good. So then what we can do, we can go find a nice number. 31 mil. That's roughly the speed of our environment, right? All right, so this is roughly the speed of our env, right? So now we can go up to 4. 4 goes to 60. 8 goes to 100. 16 goes up to 241. So you see what I'm doing here is like I'm getting us these best cases. So because like now what we can do here, now we can basically simulate breakout exactly, because all we have to do 118, so it's like 480 bytes, I believe. So that's breakout right there. Right? And now if I go to 16, we can see it should actually be able to be it should be able to be reasonably quick here. Now the problem is we also don't know all the other write patterns. So this is still kind of synthetic in a way. I mean, but this fairly small workload, it looks like it's supposed to be able to scale decently. I think more realistic would just be to like run OpenMP, right? Yeah, so I think what we want to basically be able to do here, so we want to be able to just run OpenMP on our environments. And once 90 mil is the max end speed that can be passed. No, we're not even on past to GPU, man. We're not even on that yet. Okay, I have some ideas for how I want to handle this then. Let me go get a mug of tea, and we will figure out how to work through this. Well, I have some ideas to do what to do with this. This is a nice little benchmark, honestly. Let me think a little bit about my architecture, because, man, I'm trying to figure out what the hell's wrong with me. Like, what was I doing with all of this? Well, I guess what I don't understand is, what does OpenMP do? With static schedule. Okay, so that's a really bad. It's a really bad scheduler. It's a really bad scheduler. Why did I not know about this and just use this? Like, am I stupid? Ooh. That's kind of cool. We can auto-tune this for sure, right? It's probably some super basic thing, right? So we probably just want to auto-tune. Every is okay. Directly to CUDA target. Wait, what do you mean you can pass directly to CUDA target? What does that mean? Well, I mean, my dumbass didn't know this existed. Well, I mean, I knew OpenMP existed, but I didn't realize it was literally like I didn't realize it was something this simple, right? I thought it was going to be some very fancy, heavy library that's a pain to integrate and that makes you change all your code. This is basically like MATLAB Par 4. Actually, MATLAB Par 4 probably just calls this exactly. Well, this would give us a reason to do auto-tune. Right, so the thing is I still need something in the background to cue the vectorization transfers, right? That's really the complex piece of it. So I'm not like a total idiot. It wasn't just like, oh, you should have just done OpenMP or whatever. Because there's the additional complexity we have with the transfers. I don't know what you mean you can you pass directly to CUDA target. Maybe you don't. Well, you would need a manager thread, right? When I was messing with CUDA, see if you find it, yeah. Okay, so this thing is completely fucking stupid. You don't even get any. Wait, what? You still get CPU GPU overlap. No, you fucking don't. I'm so confused. I think it's just insane. Async completes during the next buffer step. Ah, okay. So it would do. I see what it's doing. It's actually that's kind of clever, but it's still bad. Are your workers idle waiting for the GPU? Oh, no, it's just completely wrong. Yeah, this is completely stupid. This looks super simple, but this is completely stupid. It like pretends to be smart. I mean, this is like it took me a few minutes, you see, though, to figure out that this is ridiculous. It's like, look, code. Ugh. Can I do... Okay, let me think of the other thing that Peru said. Because it's the one other thing. Mm. I have to think about this. The heck? Yeah, so we do this. Multi-threaded GPU batching. Where's the file? Oh, okay, hang on. I was thinking of OpenMP target, but just makes it run on GPU. Huh? That's weird. Yeah, so where is the. Yeah, there's nothing in here. Did he not commit the code for this? I mean, it looks to me like he didn't commit the code. Because I don't know where on earth this would possibly be. Oh, hang on. He put it here. Should I do a PhD? I never tell people to do a PhD. You should do a PhD if you want to do a PhD. I don't ever tell people, oh yeah, go do a PhD. Call forward eval batch to run full BPT across all segments. Hang on. Wait, forward eval batch. complicated. Now I have to freaking think about this. Brr. I'm so confused. Like, Peru says this has good results. I have no idea how. Wait, 12? 8 GPU batches. I'm very, very confused by this. So what do we do with this? Because, like, we have this whole optimization where Peru says he has this thing super fast here. I don't think I can even pull this out easily to test. Can I? Well, let me think if there's a simple way I can do this. So actually, I think I can, right? I mean, he's just like queuing up everything. Let me think about this. I think I can probably. I should need to go. Actually, I need to go double check one thing because I've missed. Let me just double check one thing and then I can fully focus on this. Yeah, okay, we're fine for now. If instead of doing this, this just becomes the OMP call. You don't have to set the state. Stream. You put it on a different stream. Does this just become massively easier? Well, the problem, I suppose, is that now you don't want to thread the PyTorch call, do you? I think that's the problem, right? I think that's why it gets to be complicated, is because you have to thread the PyTorch call. The only thing is you have to put the frickin' torch call into this. Yeah, that's annoying, but it's not that bad. Or synchronizes internally. That doesn't make any sense, does it? Yeah, that's awful design. Ugh. Vectorization is hard. Yeah, vectorization is very hard. I'm trying to figure out why this is even supposed to be a good idea. I mean, it's like just basically Peru told me so. I fundamentally don't understand why this is a good idea. Oh, wait a second. I think I see. No, I think he's right. Hmm. Hang on. If the GPU is slower, if the GPU is slower, then by the time you're ready for more data, it's there. If the CPU is slower, I have no idea why this thing is as good as like as much of a speed up as he says. I mean, I could just try it. It's basically set up already. And then you just make two backends, right? Oh, not really. You could still do it in one. I think this is worth trying. Yeah, I think this is worth trying. We'll just we're gonna make a bit of a mess of this, but we can try it this way. It'll keep the same interface. We can time it directly. Yeah, we'll see on this. Here's the restroom. I'll be right back and we'll do this in another hour or two. Create threads. Okay, perfect. I actually can literally do it right here. Args. Yes. Need any of this? Okay, so now instead of C thread manager, we need to take OMP thread manager. Worker arg takes index. Does it care? Takes a backend. Yeah, it needs to know which ones it's responsible for, right? So we just do oh, it already takes a backend. So actually we don't even need to care. Buffers. It's fine. And now in place of the manager, we're going to do right here. It's going to be much simpler, I believe. Set states. Yeah, it's going to be tough to get the PyTorch net into this. It's the only annoying thing. Do I give it a function pointer? Magic function pointer? Maybe we do something like this. For the graphs. Thread manager. Damn. Horizon. I think that I have it. Like, I think it's not that hard if we just do it this way. Like this, yeah? Star. Call. Call before. Is there a CUDA stream synchronize? I think there is a CUDA device synchronize. And then there is a yeah, it's like this, right? Hang on. Okay. Synchronize. Whoops. Do not need this. This. Then we do whoops. Uh, and then you see step the end, right? And then you need to do the async copies, which is all this. And you do CUDA stream synchronize. And then you're done. Right? Something like this, I think, could work. So okay, several MS. Several MS is quite bad. So you do need to reuse these. I think I can get Claude to do this from here though, because it's literally, it just needs a couple of flags. If I'm careful, I think I can get it to fill in. Because this is the chunk that I wanted to write myself. I think it is this simple. We can probably use the existing flags. Let's see if it's smart enough to do this. I think this would be so much easier if we can do this. Like, so much easier. Right? Is literally one screen of code. Yeah, well, I mean, honestly, Carpath is at least more correct than most here. He's slightly off base with some of the LLM stuff, but at least his takes are nowhere near as stupid as the average Twitter user. Okay, yes. This is fine. I think I'm going to do this different. I don't like what it's done with the void type here. I think I'm going to cast it in there. Okay, let's see what it's done here. OMP thread manager. Call before. Okay, I don't like what it's done here. Vex end. This is fine. Yeah, this is completely wrong. Nice job, Opus. This is what I mean. Like, I can get it to do it if I pay attention, because otherwise it makes a total mess. But it's been a while since I looked at this, and I think that this integration it can do easy enough. Okay, void star, call before, yep. Okay. We no longer need these counts. I don't know if that's the right syntax. That's weird. That might be correct, the void star. That's just weird looking. I never do it that way. Yeah. Why you get rid of my CUDA stream synchronize? Okay. This is fine. Just change to call this from the test. if this works, if we can get this to work, yeah, if we can just get this to work, then we can test out the speed diffs, and we can get a very nice answer. Okay, that's good, actually. We do it first with this. So we see if we didn't break anything. It's fine. Oh, there's M, PufferLib, PufferL. So first, we make sure that this still works. God damn it. Hang on. Let me Docker stop. I hate like stupid Docker just drops CUDA randomly. It's so annoying. Okay. So this one runs, right? This optimizes. This is good. Now we build the torch. And this should be calling the same code. Okay, we did not break anything. That's very nice. It's going to be a little gross with the function handles initially. I think it can actually be a single function, right? Yeah, you just need one callback. Make it a different function. Because you just take the entire loop, right? Or the entire contents of the loop, and you stick it in an opaque pointer. That's fine. I do it like that. Yep, net callback goes at the top. These are very small little things. So pretty much the plan is we're just going to hand this thing a pointer that's to the entire net forward passing copies, including the graph logic. And then the rollouts will just be done in that. So we'll just have like one call per buffer. And then that actually does it the way that Peru is doing it now even. So we get additional parallelism potentially. And then we'll see if training matches perf and if it's faster. What is it doing? Extern C. Yes, this is fine. Yeah, this is fine actually. The extern C is a little sketchy. I think it's getting confused where this is getting called from. Okay, so let's try this. Because now this should work. FLTO option. Serial compilation, okay. Let's build. So this should still be using the old path. Okay, this is still using the old path, good. Yeah, rollout simple is. Yeah, this is not gonna do the same thing, dummy. Be fine. I mean, in theory, this should work. It's really freaking janky for now, but I'm hoping if I can just get this end to end and test it tonight, I mean, that would be great. Barring synchronization crap or like DLL crap, um, it should just be fine because it's the same op. It actually has less room for sync to go weird. I see what's wrong, why it's getting confused. I see. Yep, this is fine. Again, very hacky. Good enough for testing. Yeah, this is exactly what we want. So it's basically you flip a flag at the start. Yeah, exactly this. Super freaking basic. But the fact that there's this bit of synchronization, now the synchronization is outside of the loop over time, should make it way better. We will see. That's better. That's better. Kind of a weird day. Um, yeah, kind of a weird day with all this stuff. If I'm correct, though, then the function in the C++ should look very simple. Wait, vec OMP step. You can't pass it a PufferL, dude. Wait, can you pass it pufferl.vec? Oh yeah, you can. Okay, nothing actually uses this. This create thread signature needs to get updated. Mm-hmm. And then this is gonna have to be the function pointer. And create threads gets updated, and then we're good. Yep, this goes there. Yep, and it got this. Create threads. Oh, I see. Wait, create? That's not how this works, my guy. That should be vec, shouldn't it? Should not be pufferall dot. Wait, true. Use. Oh, actually, fine. It just did it weird. Pufferl dot get. It's a really stupid way of doing it. We'll have to clean that. I don't even know if that works, to be honest. Weird C++ things. Okay. It's on. Plays. Yes. Yes, Ethan. Try this. Heh. That runs? Interestingly, okay, it trains sort of. That's not what I was expecting. Why are you creating threads? Because it's buffered. It's more complicated than just one layer thing. I believe it uses threads internally as well. I don't know if it actually uses processes. Think about this. Sign reward? No, it's not learnable. Wait, where did you even see that on my screen? Oh, you didn't. I'm sorry. I did something else with a sinusoid for a dummy, and sign of reward is learnable. What? I don't know what sign of reward. You mean if the reward is a sign function, is it learnable? If you can observe the time, then yeah. Or if you can observe the reward, that would also work. Wasn't following. No, 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 Ethan. You were asking something else, I think. I had a sign and an env earlier, so I thought you were asking about that. But that was something totally different. Does it work with one buffer? Yeah, it does, doesn't it? Let me try it without coup de grace. See if it's a coup de grace thing. Uh-oh. Yeah. Yeah, it's not a coup de grace thing. It's a buffers thing. Let me see if I can spot it. Net callback. And then you synchronize. Ooh. Oops. Yeah, that's my bad. That was really stupid of me. That's totally what it is. I don't know how I forgot that. Well, I know exactly how I forgot that. There's a million bloody things going on. Okay, fine. We'll do it this way for now. Well, what was on your mind that day? I don't know. I thought it would be fun. I streamed some games for a bit for fun. While I was doing my PhD once in a while. So I figured out, that was kind of fun. Let me see what happens if I just stream my dev work. I figured like maybe it would give me a way to like narrate my thoughts out loud. I thought it might help me focus, and it ended up being very enjoyable. Yeah, this is fine. And then it gets a specific graph. Wait, what? You idiot. I feel a bit exposed, you think? Not really. You get over it very quickly. I mean, I do stupid shit on here all day, but I get stuff done. So, I mean, the idea is just like, alright, if you're so much better at everything, then be my guest, solve RL. Until somebody else decides to do that, I will be sitting here bumbling my way through it. Coup de graph rollout graph. Hang on. Not really. It's not as I get as distracted on my own as with this stream. So it's really not any sort of time loss. Copy graph. Yeah, so you just need per roller, that's fine. There we go. This is fine. I want to separate in a moment. I'll have to separate this one, but I mean, we'll see if this is even faster. It is actually quite a bit simpler, to be fair, in some ways. Buffer raking money. I mean, we're profitable already. We are lining up a bunch of contracts. A couple new contracts at least quite soon. We have active ones as well. This is fine. There's gonna be so much stuff to freaking clean up. I think Thursday is gonna be cleanup day if I can get it to work today. Yeah, so basically this is just having to do an extra set of traces. It's not even really an extra set of traces though. Like the copies, it's the same number of traces. So really the only thing that you have to do a little differently is you have to trace, there are two different intermediate buffers now. What the heck is this doing? Ah, I see. Graphs at 0, that's totally fine. That's exactly what I would do to cheese it. RL's next thing, society should value it. They will. I mean, I think it's going to be very profitable. It's my secondary motivation, for sure. Dota on a 4090 in a weekend. What would it do though, Dota on a 4090? So if Dota were, I think that if we could get Dota to run on a 4090 in a weekend, given like a really fast Dota sim and optimized architecture, how much steps could we do with that? let's say that we got that running like a pretty small model at like a few million steps per second. Let's say 10 bill an hour, 240 billion steps. You might need more data than that, to be fair. Maybe with algorithmic advancements. Look, if we could solve Dota in a weekend, oh, 240 bill per day, so 500 bill. If we could solve Dota in like 500 billion steps with a tiny model, um, I mean, that RL would be substantially more powerful than any of the LLMs these stupid companies have. Because you basically just point it at some sort of fiddly, unintuitive optimization problem and it will insta-solve it. So like, yes, oh, like, oh, haha, it solves a game in a weekend like that. No, what that represents is like completely superhuman intelligence. That would be absolutely insane. You'd pretty much just be able to hook up any problem you care about to a like in a fast sim and it will just solve. Are we at stable alpha yet? Jess, I'm trying. Maybe Thursday. This shit is hard. We stable at least? Okay, so this one is stable. So now we have an alternative vec backend. It is slow though. So let me go look at the synchronizations that we were doing before. 5 bill, what is the distance to that? So with Puffer 4, I think we'll pretty much have the speed for that with these small networks. There's probably a pretty big algorithmic gap, though, to being able to solve problems that hard, that quickly. That's going to be Puffer 5 objective. And we also need, like, actually hard benchmarks EMs to throw this at. Like, we do not have a version of Dota that just runs super, super fast. So in some sense, if we had more environments that are hard but have smooth progress curves and that run really fast, that is directly helpful to research, right? You streaming Wednesday? No, Jess, I've been doing like Tuesday, Thursday, Saturday. Wednesday is probably gonna be, well, I've got one doctor's appointment, I've got a couple calls, I've got a big gym session, and then I probably gotta fit in a little bit of client work. Reinvent Dota in C. This was my attempt from when I was brand new to C. It's literally the Dota map, one for one, ported in. Like, this is the Dota map. It's just kind of like, it's kind of simple, and it turns out that if you don't have self-play solved for this, then you'd actually need a good scripted opponent to play against. And also, like, the move sets I put in are kind of too simple and stuff. But this is a pretty decent base, and it's pretty quick. Yeah, so once we have self-play that's stable, Jess, we could probably revisit that MOBA env. Like, that's a pretty good starting point. So wait, we synchronize before send. No, single thread synchronizes. Okay, so this one is just an async copy. And then there are actually no synchronizations in here at all. So actually, it just synchronizes. Hmm. Let me think. Once this synchronized, so you do send. Let me think. So I think we can just put one device synchronized call. It's before send. What does that mean? Right, it's just we don't know. Okay, so it's right before send. So I think then, hang on. Transfer actions. Yeah, so this is the only one that we need is a device synchronize. And then you do have to synchronize the stream. So wait, this is fine then, no? Your name sounds like chess. He's got you there. I have 16 cores. Each step's its end sequentially. No, you absolute moron. We also have multiple schedules and things to play with. Yep, that's good. This is still way slower than before. Yeah, it's not doing it. It's not actually using the threads. It's equals 4. $9.50. It's probably better than I am. Actually, it's definitely better than I am. Still no. Okay, so it's not just slow, it's not vectorizing correctly. Yeah, but we're not doing search, Ethan. That's the point. The point is we're not doing search. Known ELO opponent. We have to use a known ELO opponent and a runs that ran longer. Yeah, so that's the problem, Jess. Like, no, you can't automate that smartly. You need a known ELO opponent to ground it against, right? Search plus RL? No. Because search is freaking slow. That's the problem. No, bro. Yeah, but the thing is, like, the point of what we're doing is not to do that. The point of what we're doing is to see, can we do it without the search? Because search scales like shit. It doesn't work on the vast majority of M's. And it is always slow, and it is always a total pain in the ass. Oh, that's nice. Well, that matches speed with our other implementation. Cool. Well, we can play with this now because this matches the speed of our other implementation. Let's just make sure this is doing what we expect. Yeah, perfect. L layer network for an N times L. The search is exponentially expensive. So the question is, what if we just run the network way more, right? Like, why do we need search when we can have the thing just play the game? What if we just have it play chess at 5 million steps per second per GPU, and then we just run that a whole bunch, right? If we get log linear in compute, we get log linear in compute. Cool, we win. And then that's a really awesome env because, we can test if algorithmic changes change the shape of the curve or like get us fundamentally more efficient, so on and so forth. At inference, oh, bollocks to your inference time scaling. That only works with specific M's like that. You don't need it anyways. Dota was solved without inference time scaling. There. I think you can just do it without that. Ooh. Hey guys. Peru is kind of right. Yo, look at this. We're at 11.5 mil. Wait, if I do 8, does it get better? No, it does not get better with 8. Alright, that's too many buffers. But dude, that's awesome. Because if I do it without this, it gets worse, right? Because that's not what we're trying to do, Ethan. Because we're not just trying to solve chess, you see? We're not just trying to solve chess. Okay, guys, we actually got this thing to frickin'... We nailed it. Good job, Peru. 11.5 mil SPS. Can you explain what I'm doing now or the chess thing? The chess thing is very simple. You cannot run search on arbitrary environments. And there's no reasonable way to be able to run search on many environments that we care about. What did we change? So Peru had this thing where you technically all the buffers can run in parallel, and they run parallel over the sequence. So I did that with OpenMP, and it looks better. I actually wonder now if I can use more threads. It probably scales. Hang on, maybe it scales with more threads now. Num threads. Search can't fly a drone, there you go. And you don't need search to fly a drone either. What you need is one fin. And one SAM as well. Yo, Finn, we're over 11 mil now. See if this does anything. Oh. Look at that. 11.8. That hit 12.5 at the end for a second there. That's damn near over 11.5 mil. OQR flies a drone. One fin flies a drone as well, with a tiny little neural net. You don't have to plan anything. Planning's a meme. Oh, this is good. Okay. I am kind of surprised that this thing worked. The funny thing is we can actually make this even faster once we figure out how to mess with the Torch CUDA streams. But I don't know if this is the best thing to do, but at the least it was better than the mess that I had before. Let's see if it does more with more threads. What was the improvement? I stole this idea from Peru for transparency. So Peru had this idea. I would have never come up with this idea on my own in a million years. So let's give him some credit. So Peru's idea was that you roll out in parallel. So all your buffers, they actually can all be going at the same time without doing them like round robin. And this made no sense to me because the whole point in my head was that, like, you know, by the time you've done one forward pass, you have more data waiting for you. But actually, the thing is then what happens is you're basically like trying to manually tune the buffer sizes to the CPU sizes. Whereas with this, if you have both buffers ready, you can run both net forward passes. If you have both forward passes done, you can run both end steps in parallel. So it's just an additional axis of parallelism, and there's really not much more to it than that, and I just massively overthought. So yeah, very, very nice. 20 mil at this rate. Finn, it actually might, because we still haven't done BF16. And the guy that did all the kernel improvements, like the last couple kernel improvements, who got us one or two, I think he got us like 1.5 mil SPS. So that guy is working on BF16. I kind of outlined it for him, like the thing I was trying before, and it'll probably work. Ah, okay, so this one's seg faults. We'll have to figure that out. $11.5 mil though, damn. Mm-mm. Oh yeah, there's one other thing we can try. It's 11.8. About the same. Oops. SPS next to star history? Eh, that'd be funny. We'd have to go benchmark it for a few different ones. This one is worse. No, it's about the same. Okay, if you make it too small, it gets worse. World model stand. You know, we are actually using them for something in a research collab we have going, but it's not for the thing that you'd think to use them for. I'll say that much. Actually, at what point is this solved in the eval here? 10. Yeah, sub 10 seconds. That's 10 seconds solve. We win. GG. There is actually a reasonable thing to do with world models for driving, but again, it's not the thing that you would think of. Well, let's commit everything. We win today. do this for now. And I'm gonna go check when dinner is. So my family's getting dinner. On my AI paper. Hots is cool. One sec. Now? Okay, 2 minutes is good. Awesome. All right. I got dinner in a few minutes. Let us just real quick. That's still crazy to me this works. Spencer, 11.8 million goddamn SPS. We win today. And it's even better than that because it's an NVEC win. And that's the big bottleneck right now. I am fried from all this stuff today, though, let me tell you. It was like 5 hours of banging my head against an SPS test, and then a few hours of like different possible ways to redo the VEC. We do add the OpenMP dependency, which is not my favorite, but that's like a pretty simple one. And the actual code ends up being way shorter and easier. Yeah, it's pretty good. I'm getting dinner in a few, but I've been live for 8 hours. I've also made a bit of a mess of the code, so Thursday is going to be like clean up the code day. Including the tests. Like these throwaway tests are going to have to be mostly thrown away and done correctly. And get like one really nice profile script. Yeah, so like my idea with all this, like letting Claude do all this crap is that we're gonna end up deleting most of this because we ultimately only need the fast path. So we've got like 4 different paths right now. So we'll only need the fast path, and then I can manually like clean up the remaining code. Yeah, like this. Two buffers, 8. Yeah, that's world model to infinite on Paul. No, that's not my idea. That's just how it works, but it's kind of crap. Holy. Okay, guys. I think that's a little bit better. What about you? Yuckity yuckity. Alright, Peru, you rock, man. Yeah, you kind of rock. I was wrong. My bad. This idea is good. I am dumb. I admit it. I'm just happy we friggin' use this thing now. Wait. One. Oh, wait. How is it faster this way? One. I don't know how it's faster this way. I must just be trolling. Yeah, I probably am just like trolling with the overhead. What did we say cap was? 80 mil? So this goes up to 60. And what with 4 threads, we get 48. We get 60. And then our best is this. 53. I think we said cap was 80 though, guys, because like, watch this. 118 times 4. Okay, and then we have 48 gigs is what we profiled this machine. Is cap 100 mil? Maybe it's 100 mil. Okay, so I think that this says, no, but that says that the maximum memory bandwidth possible for this, if you're just doing transfers, should be 100 mil, right? Oh wait, are we profiling on GPU or not here? Ah, All right, I gotta go, guys. I gotta get dinner. We'll continue this on Thursday. If you want to help me out for absolutely free, this puffer likes stars. Feed him a star on GitHub. We're almost to 5,000. I've been slacking a little bit on X and stuff because we've been working on things. So yeah, come on, help me out. Feed him some stars. Almost there. I stream all my dev. You can join Discord if you want to get involved. You can follow me on X for more content now and again, sometimes articles. I need food.